All right. So generally use computers, and the computers are fitted with different models. Models are kind of the programs that you put those initial conditions in. These are kind of some different variations of numerical weather forecasting. So, for instance, climatology forecasting, don't need a computer. Basically, you just, based upon what you know about the climate for that time of year. So, like, for instance, we could say around here we're expecting temperatures to be this time of year, like between 50 and 70. Okay, so that's your forecast. That's climatology forecasting, not climatological, climatology forecasting. Okay, you don't need a computer, right? You don't need a computer for this one either. Persistence forecasting. So if somebody persists, that means they keep on, keep on, keep on, keep on. So in persistence forecasting, we assume that the weather's going to keep on, keep on, keep on, keeping on. And some parts of the world, it works better than others, okay? I'm told that, like in Hawaii, they kind of have this kind of ongoing weather pattern, okay? Here, especially lately, you can't count on what you have today being what you're going to have tomorrow. But that's persistence forecasting. Again, no computer required. You need a computer for this one. If you're familiar with the word analogous, analogous means like the same as. So you have an analogous, in this case, an analogous situation. So in the analogous approach to understand, to put forward a forecast, basically you go back in time and find an analogous day to what your day is now. Because you know your conditions, you know what all that stuff is telling you. So you go back and you find a day just like today, and then whatever the weather was the next day, that's your weather tomorrow. Kind of strange, but again, I think you need a computer to do that.
You don't technically need a computer to do that. All you need is the Farmer's Almanac.
Could be.
That's basically what it is.
Yeah, it does some of that. Trend forecasting and nowcasting, and both these terms made it to your review sheet. Trend forecasting does what Benjamin Franklin did. Trend forecasting says, we know that we're under the mid-latitude westerlies in the Ferrel cell. Trend forecasting says we can definitely just kind of look upstream, okay, get a sense for what the weather's going to be like. Now forecasting is actually like trend forecasting, but it's closer to home. Okay. All right. So upper elevation weather maps. We've kind of talked already that basically, for instance, we said in order for a high to be sustained, that high needs to be fueled by air moving down from a loft. So we definitely have this 3 dimensions going on. So we need to know what's going on in upper elevations. They come up with these what's called isobaric maps, and I think we talked about isobaric maps. Basically, they are heights that you need to be to get to that particular pressure. So if at the surface we're running about 1,013 millibars, if you go up a little bit, you have an 850 millibars. You go up a little bit, 700 millibars, up a little bit, 500 millibars, 300 millibars, 200 millibars. So honestly, these 200 millibars isobaric maps are talking about the upper parts of the atmosphere. So these are familiar terms. We talked about, basically we can have kind of, where are we? Where's North America? We can have kind of these wiggles in the jet stream, okay? We call that meridional flow. And then we can have straight flow called zonal flow. And actually, the waviness or the straightness is definitely, a player in anticipating where your weather systems are going to go. So here's a 500 millibar isobaric map. Okay. So, did I say 500? 850 millibar isobaric map. So this one will be pretty close to the surface. And you can kind of see some waves, a trough and a ridge, kind of like we talked about before. Again, these would factor into the programs. So that was 850. This is 500. Find 500 millibar isobaric map. The wind should be stronger up here. Kind of see some similarities. And this is the 200 millibar isobaric map. Notice the pink now, that's that fast-moving ribbon of air we call the jet stream. So these all kind of go together. Speaking of jet stream, and that's the one, this is the jet stream between the polar and the Ferrel cell, the polar jet stream. In general, if your jet stream is running kind of strong, okay, that will intensify your storms, your storms here in the Midwest. Okay, a strong jet stream in general should knock out hurricanes, though. So I don't know if it always works that way. Okay, so a weak jet stream will actually then allow for hurricanes to do their thing. So that's kind of a connection in general. All right, almost a live slide, right? So we have these, no, we have a few more slides. We have these long-range forecasts. And what comes to mind is kind of like what was set up here. To me, the long-range forecast, and I brought mine from last year here. I didn't get one for this year. Okay. But the Farmer's Almanac is great at giving long-range forecasts. So this one is for 2014, but it gives like for months in advance for this general region. Right? So long-range forecasts can be done oftentimes in 3-month segments. Oftentimes to understand long-range what's going to happen, we look at the climate. Statistics, again, use computer models. Long-range, we can also factor in what sort of pattern we're in the southern oscillation. Is it El Nino or La Nina? And here's just kind of a random example of a 3-month long-range forecast for this given year. Is it accurate? Maybe. So speaking of accuracy, why do forecasts go wrong? And actually there are 3 reasons, and this actually was like the last term on your review sheet for this chapter. One is the programs, okay? So remember the things you put in the computer? You're assuming that you can correctly anticipate how Mother Nature will behave, okay? And that's not entirely always so, okay? Another problem, and the reason forecasts go wrong, is that play, that uncertainty, the butterfly effect. We talked about with the temperatures having even a range of real temperatures. And then the third one, so if you want to go 1, 2, and 3, that's what these are. The third one is when we try to get initial conditions to feed our computers so they can run the programs, we are missing we have a lot of holes. Okay, we have planes flying over, we have little buoys here and there, but for instance, oceans, like, I don't know what the initial conditions are out there. Okay. So yeah, it's the old adage, I wish I had a job where I could be wrong so often and yet keep my job. So with regard to seeing if they're successful or not successful, there are certain ways to measure that. So if someone talks about how well they can forecast the weather, okay, there's something called forecast skill. And forecast skill needs to be actually going out on a limb. So that's to say, when I said a minute ago, I forecast that the temperature tomorrow is going to be between 50 and 70. Okay, that doesn't take much skill, although tomorrow it's going to be warmer than 70, I think. Okay. So I'd be wrong.
I hit like 77 today or something like that.
Yeah.
That's cool. Feels good.
It's supposed to rain tomorrow, though, I think. There's
Yeah.
a little chance of it. Not a very big chance.
Race day tomorrow, it ain't gonna rain.
It'll rain, but not very much.
So you need to go out on a limb in order for there to be skill involved. Then we have quantity or quality. Quality has no number, so that would be like, is it going to rain tomorrow, kind of? Yes or no? Yeah. But there are some things that have numbers, like temperature, okay? And then you can actually do a mathematical statistics thing to knock out accuracy.
100% chance tomorrow. It'll be all right.
What's that?
20% chance.
20% chance of
With
precipitation?
10 mile an hour winds. 79's the high.
Right. Oh, in a minute, I'm going to go to a website. Where'd you get that information
Weather
from?
Underground.
Okay. So, actually, somebody's out there keeping track on how Weather Underground does, how the Weather Channel forecast, how National Weather Service, how they all do relative to putting stuff out there. Okay. So, forecast bias means, and I've always been curious about this. I haven't tracked it down, but so like, does it always overestimate or underestimate the high? You know what I'm saying? I mean, well, I guess the high should always be overestimated. But you know what I mean. Like the temperature that is supposed to be tomorrow, are they always bias high or bias low? What you want to see is no bias. You want to see scatter, okay? But if in analyzing their own forecast, if they come up with a pattern, they're always high or always low, then they actually should rethink. They should rethink what they're using to put forth to come up with their forecast. So this is the thing I was telling you about, and actually I put this out on Twitter feed. I think I'll try to double check. But you go here and you put in your zip code, and they will come up with an assortment of people who are forecasting, organizations that are putting out a forecast, and they will tell you how they fare. And so I was kind of playing around with different zip codes. Forecast advisor, 52632. I think it's going to come up with Burlington, but that's not too bad. So there's the forecast for Keokuk tomorrow and that sort of thing. Saturday rain. Oh. Okay. But what I wanted to show you is this stuff down here, where it says Weather Underground runs about 81% accurate. The Weather Channel, I'm not sure what forecast is, but AccuWeather, less than that.
I hate AccuWeather.
Really?
I don't think it's very accurate at all.
I don't know, but apparently this would say that too. The National Weather Service, 76% as opposed to 81. That could be significant.
To be fair, though, we have a lot of parity in our weather. You never really know what's coming.
Yeah, it could be. If you click on the tabs up here, they'll kind of explain how they got their percent accuracy. But I think it's interesting, too, if you look a year ago, how was it running? Hey, that's pretty cool. We're getting better, aren't we?
Yeah, I guess AccuWeather, I did start hating it last year, so it was 70%, so maybe that's more. Yeah, maybe it got better.
Interesting.
Yeah.
WeatherBug was number 4 last year. It's not even on the list this year.
It's so bad. It just, I didn't even waste their time.
There's a reason for that, and nobody else picked it up.
Sure.
It's because the Weather Channel bought WeatherBug.
Oh.
WeatherBug.
So I thought that was interesting. How are they doing compared to everybody else? So now these are the last few slides. So kind of the cone of uncertainty we did with hurricanes. Basically, the farther out the forecast, the more likely it is to be wrong, right? But so very short range forecasts will be 0 to 12 hours, and they're most likely to be most accurate. You can identify thunderstorm systems, but you can't identify individual thunderstorm cells. Going out a little bit further from very short range to short range, 12 hours to a few days. So notice this thing about how they've gotten better with regard to hurricanes. Let's see, no hurricanes. Yeah, in 1985, the cone of uncertainty would extend to 336 miles. Okay. In this short range, now they're talking about 111 miles. Okay, so the wiggle, I mean, that's good. That's the right direction. Okay.
Especially when you think about how actually large the hurricane is.
That's right. That's true.
How big are they?
We said the eye was like 2.5 miles, and then the spiral rain bands off of that. So.
25, 30?
What's that?
In diameter, 25, 30 miles in diameter, maybe?
Could be, yeah. Could be. And then we get to kind of out a couple of weeks. And again, definitely improving. The skill of the 5-day forecast has doubled since the 70s. And then extended range forecasts, the less useful, but can be helpful. Oh, and the last one is kind of what we looked at before, kind of the 3-month sort of forecast. All right. So that concludes that part of the lecture.